Bismillah ar-Rahman ar-Rahim. Dear students, I am Ahmed Mumtaz Mustahsin. I have been given the responsibility to teach you the course Introduction to Computer Programming. The course code is CSC 141. Students, this is a 4-credit hour course, and by this time you might know what does 4-credit hour means. 4-credit hour means that 4 within bracket 3, 1. It means that you need to spend 3 hours per week listening the lectures, and 1 credit hour will be granted to you for your hands-on exercises and the time that you will spend on your computer as if you are working with us in the lab. This 1 credit hour is not 1 hour. 1 credit hour means that minimum you are required to spend 3 hours per week doing hands-on exercises, so then you should be able to get the credit and award of 1 credit hour. So basically this 4 credit hour course means you are required to spend 6 hours per week, 3 hours listening the lectures, so there should be on average 2 lectures, and we assume that 1 lecture should contain the material that is equivalent to the material taught in 90-minute lecture. And so with the combination of 2 lectures and 1 hands-on exercise on the computer will earn you 4 credit hour per week, and that means we need to spend 16 weeks together in order to award you 4 credit hour course. Just quick introduction to myself. I've done my master's in computer sciences way back in 1979-81 from Quaid-e-Azam University, and I have got my specialization, spent 3 years in France, and got the opportunity to work as a expert of the student of the satellite image processing. So I've spent 16 years exclusively working with the satellite image processing and GIS. So over and above, I have spent around 30 years, more than 30 years in the industry, serving either in the educational environment or education institution or in R&D environment. I have served as a middle management and the top management in different national and international organizations in different capacity. I've got an experience of doing hands-on, lot of hands-on programming, and I've done programming, started my programming with Fortran language, and then later on I've done a lot of programming in the assembly language. Then came C language, and it was introduced after my graduation, so I have learned it, and then I have taught it, and also I have used it in a number of multinational projects. So I've got sufficient hands-on programming experience, and I've contributed it in the number of projects of national interest. So I'm sure that you will enjoy working with me. I'll be giving you hands-on demonstrations, and I will try all my level best to teach you the skills and art of the programming in C language. The introduction to the course, the objective of this course is basically to introduce the computer programming using C or C++ environment, the fundamental concepts of the computer programming. So you will learn the basic concepts of programming, not only the programming, since this is the first course, so I'll also be covering some basic fundamentals of IT and the basic fundamentals of the computer sciences. So then I'll be teaching you the hardware, software, and the concepts related with the computers and IT. So the course in this particular course I'll be focusing on the structured programming, means start with the structured programming and also let you know what does the structured programming means and what is this programming paradigm. And then at the end of this particular course I'll be introducing you the concept of the object-oriented programming. We'll be using and mixing up the different terminologies that are common to C and C++. So just don't be confused and don't worry. In the final lecture, I will explain you a very precise differences, which are very few, by the way, of the C and C++. But the overall difference is that C is considered to be a structured language, programming language, a structured programming language, procedural language. But the C++ is considered as an object-oriented the programming paradigm. So that is the objective of this particular course. The course outline that I will put it up into the web portal, the course portal, that I will invite you to have a regular visit on the portal and see the information and the instructions that are provided to you to study this particular course, or maybe some other courses also. So this should be a regular feature for the students to have the visit or to browse the course portals for all the registered courses and follow the instructions passed on to you. So the course outline comprises introductions to computer and language. I will be talking about components of the computer, types of hardware, software, what is that, the language history. Then I'll be introducing you the Visual C++ environment, IDE. IDE is basically Integrated Development Environment. I had thought about it, at what environment I should be working with you and teaching you, and after a lot of thoughts I decided that I should be using the Visual Studio, and within the Visual Studio we have got a Visual C++. So I will be using this Visual C++ environment that has got an integrated development environment, means it has got all these facilities which are required to key in your program, to write your program, then to pass on different steps that are required to execute that program. So it is a self-sufficient environment, and don't worry, I'll teach you how can this environment be set up at your home or at the facilities where you will be doing your hands-on exercises. We'll be discussing the algorithms and flowchart, that is the program development steps. So how can you organize your thoughts, put them together and define the procedure to solve one particular problem or any given problem. And then the difference between that algorithm and pseudocode, describing basically the algorithm in as per your convenience, is either in a pseudocode or in flowchart, that I'll also be teaching to you. Then we'll talk about the syntax, the semantics, syntax of the grammar of the language. Semantics means the meaning of that grammar, keywords and basic concepts related to the C, the data types, and some related concepts. Then the control structure available in the language, that is the if structure, then the loop, repetitive structures, and the compound statements that can be used with this control structures. We'll talk about the functions, then the very well detailed explanations of defining, declaring and using your own functions and passing on the arguments to the functions, and different ways through which you can pass on to the function. Then there is a concept of recursion, so we'll be talking about the recursive procedures, and then we'll talk about the recursive functions also, and I'll teach you that how these recursive procedures work and how this recursion is implemented and used in the C environment. Then a structure which is called an array structure. We will be spending sufficient time on arrays, and we'll talk about all the concepts related to the arrays during the topic of arrays. Then the string is not predefined data type in C, but it is defined with the help of some other defined data type, which is a character data type, and we will see that how can we define strings and then how can we manipulate strings. The strength of the C language is the pointers that are available to process and handle the data and manipulate the data. So we'll be spending sufficient lectures and time in learning the concepts related to the pointers and arrays and manipulating the arrays using the pointers. Then user-defined data types, which are structures, unions, and enumerated data types, that we'll also be learning in this particular course. So there is a power of the C language that it allows you to handle and process the data up to the bit level. So that feature is a very, very good and powerful feature available in C language. So I think that we should also cover this topic in this particular course. Then we will like to save the data permanently and for the future use also. So for that purpose you need to learn the concept of creating the file, opening the file, closing the file, reading and writing into the file, manipulating the files, different types of files, sequential files, random access files. So these topics we will discuss. Then there is a very common feature the students usually prefer and they insist to use a feature that is available in C language, which is C in and C out, and consider it much convenient and easy and fast to learn, and that is these IO streams. So I've decided that this topic I should also include into this particular course. Then finally I'll be talking about the difference between C and C++ language, and we will conclude this course by discussing the design paradigm and give you a bit taste of the object-oriented programming, so that you should know the difference. Before in any advanced register course of object-oriented programming, you should have certain basic fundamentals and knowledge. So students, it might be an over-ambitious course outline that we have decided to put it into this particular course, but I am very much confident that we should be able to complete these all topics in the next 31 or 32 lectures that are scheduled in this particular course. The books basically for covering the programming concepts, I think that the books that the very common and basic book that is available from the Robert Rafford, and this is basically a Turbo C. To start with, there are topics that are very well explained and available in the Turbo C. Then there is another book which is called Let Us See, and that book also contains some very good examples that I would like to use it in this particular course. For the introduction to the IT concepts, the computer science concept, a very nice book available from Peter Norton, and that is Introduction to the Computers. This book is available. You are not supposed to be very much fussy regarding the edition, the latest edition, or basically the basic fundamentals are available in any edition. So I will not insist you to buy and purchase and have a specific edition. Normally the editions which are commonly available in the market are basically the 6th or the 7th edition which are available to you. But even if you find the 3rd, 4th or 5th one, don't spend too much time to go for the latest edition. Then there is a very nice book that is Detail in Detail. This is C, How to Program. Be careful, there is a book which is called C++, How to Program by Detail in Detail, same authors. almost the same name, but I will recommend you don't buy C++, buy C, how to program detail in detail. Once again, I've got in my library, personal library, 4th edition that I like it very much, and I've gone through it a couple of times. I've also got 5th edition, and for this particular course I've purchased a book for you, and that is the 6th edition that was commonly available in the market. So students, please don't be fussy again, because we need to learn the concept. So whether it is a 4th edition or whether it's a 5th edition, 6th or 7th edition is also available in the market, but you should be concentrating to the lessons that I will be delivering to you in this particular course. So whatever, there should be at least one book with you, either it's a 4th one, 5th one, 6th one or 7th one, but the examples that I will be providing you should be sufficient, but still it's not possible to cover each and every example given in this book. So this book I'll be using for both text as well as for reference. So sometime I call it as your reference book, and sometime I call it as your textbook. So I cannot distinguish this particular book as a text or as reference, because I think there are 3-4 chapters that I have picked up and decided to teach you in this particular course. The websites I will provide you on this portal for that. I picked up a lot of material and examples from the internet, and that is the one of the very common source available to all the students and teachers. So sometime I have picked up these slides also, but these are from the official websites of these reference books mostly, and sometime I have picked up these slides from some university's website also. But for every lecture, in my first slide you will find the reference to those slides, because this is the copyright, and we respect the copyright of everyone who has contributed and produced the material either for learning or either for teaching. So whether it is a teaching resource or whether it is for the teachers or whether it is a learning resource for the students, we appreciate that, and there is always it should be acknowledged, and I have tried to acknowledge each and every the website from where I have picked up the material. I have also got the material from my fellow colleague, which is Dr. Sadaf Tanveer. She is teaching this course in the campus. So she was very kind enough to me, and she has provided me the material that I will be using, and I have decided to use around 25 to 30% material, or maybe around 50% material that she has provided it to me, and that you will also get it in the form of lecture slides and demonstration exercises. There are a few more reference books that I've got in my library and I've got available to me, but whatever I will pick it up, I will provide it to you. Don't waste your time in searching these books, and I will not be using it extensively, but there are few concepts, some very good examples and some material that is available in these books that I would like to use it and as a reference during this particular course. Demo sessions. Since this is a 4-credit hour course and you need to spend 50% time in doing the hands-on exercises, as I said, it's a 1 credit for web, but this 1 credit means 3 hours, and so 3 hours teaching means 3 hours listening to the lessons, and 3 hours means you have got equal share, means you have to spend 6 hours, 3 hours hands-on exercises and 3 hours listening these lectures. Might be you require to listen some concepts again and again, so you will be having the video available to you, and then you can use it as per your convenience and as per your own pace and as per your convenient time. So all the registered students are expected to have an access to the computer having Visual C++ installed on it. So how can you get the Visual C++ installed on it? We will show you, rather I will show you, how can you install Visual C++ at your computer, at home, or in the labs where you can spend some time and perform the hands-on exercises. So I promise that I will do it for you. At the end of every lesson, or at the end of every topic, not at the end of every lecture, but once I will complete one particular topic, one particular lesson, then I will try to cover it up in the hands-on demonstration session. So I will be spending some time with you and demonstrating you how can you test and execute your programs and run your programs and verify the concepts that I will be teaching you during the lessons and during the teaching sessions. So we will spend some good time in the demonstration session. I will be a little bit fast in saving the time in typing, and instead of typing each and every line, I will be bringing the typed text for you, but I will put it up into the environment and I will show you how you can use that environment, what are the features that are available. So I will try my best to make you comfortable to spend some hands-on, spend some time doing some hands-on exercises for you. So students, you are bound to do some practice. You are bound to spend some time doing hands-on exercises. This course is not a theoretical course. This course is a practical course where you are expected to have a good hands-on experience. I'll teach you that whether the programming is a skill, or whether the programming is an art, or is a science, or it is something else, that we will talk about it. But whatever the programming is, you cannot learn it, you cannot expert of programming unless until you do it by hand. And once you do it by hand, don't take it as a pressure. Just, I will advise you, just enjoy it. Just enjoy doing the programming. And if you just take some pressure of that, then it is not good and you will not be able to learn the fundamental concept. But if you enjoy it and you enjoy doing the programming, then I assure you that you will learn it very fast and very quickly, and you will find out some secret tricks and the traits related with this particular programming language. So we expect to deliver 32 lectures that include some demonstration sessions also. Then there will be around 4 quizzes, and there should be 2 midterms and 1 terminal examination. So around 8 lectures time, after 8 lectures time, we'll be holding the first terminal session, and then again 8 or 12 more lectures, then we have a second sessional, and then after more 12 lessons or lectures, we have the terminal session. So between from the start up to the first terminal session and the midterm session, we can call it as, you should have 1 quiz and you should take 1 assignment. Then in between first midterm and the second midterm, you will be required to take 2 quizzes and or maybe 1 quiz and 2 assignment, or 2 quiz or 1 assignment, and whatever we will feel convenient after that. And then after the second terminal examination and the second midterm examination and the terminal examination, we will be holding a very comprehensive assignment, and we are required to take that assignment together. I'll be giving you the assignment, you will provide us the solution to that particular assignment, and after the time I will also provide you the solution of all the assignments that I have given to you, and all the quizzes. Will also provide you the solutions to the midterm examination, and also provide you the solution for the final examination. So we'll be holding this practice demonstration sessions also, maybe we'll be holding some practice quizzes also, practice assignments also, and demonstration sessions also. So that's the way that we have decided to deliver this particular course. So we start this course, and we start with the fundamentals of the computer concepts, and that I would like to go through it very quickly. Maybe in 2 to 3 lectures we will be finishing this fundamental of computer concepts, and whatever the concepts that are required to explain, that we will do it during the teaching of the programming. So, computer. What is computer? A programmable multi-use machine that accepts data and process or manipulate it to convert it into information. Okay, it is a machine that take input as a data, process or manipulate that data, and produce information. So we have discussed data and information. There is a relationship between data and information. The data is basically the raw fact. Your name, my name is a raw fact. The title of this course is a raw fact. Our date of birth is a raw fact. But when we process this raw fact, for example, we know that this is the date of birth, and suppose we want to know how old are you, or when I am going to be superannuated. So when I am going to be a 60-year-old, so what is my age? So that we can process with the help of computer. Because the computer, you know that what is the date today, what is your date of birth, then you can find out the difference, and then you can find out your age. So basically this is the manipulation of the data that you have provided. You might have got the schedule available of all the flights. You put them together on the computer, and then with the help of that scheduling you can find out the number of flights which are scheduled for one particular week, which are scheduled for one particular month, or you can process the information and find out how many flights are going to Europe, or how many flights are going to Scandinavian country, or maybe the Stockholm, how many flights are available and what are the possible dates available. So you will extract and present this information, you will manipulate this information, and this manipulation and processing is called basically the processing basically, and that converts this raw fact to the information. So processed data on a computer is called information. Then there are some blocks, building blocks that constitute a computer system. That's not computer, that's a computer system. Obviously any computer system should have a computer first, but we discuss it in the form of a computer system should have a data. This data is for the users. Basically you process the data for the users. So you first of all you need to have a data, then you need to have the users who operate it, who manipulate it, then we need to understand there is a hardware, and alone hardware cannot do anything, then you need to have a software. So let us explain. We have already talked about the data. Data is basically a piece of fact, and computer organize and present the data in the form of information. Then the users. Users are basically the persons or the people who operate the computer, and the users are the users of the computer for which the computer carry out the task. Okay, the computer is working for the people. So users are the most important part of the computers. They tell the computer what to do, and they are basically the demanding people for the reason the computers are getting advanced and faster and faster, and having the more and more working space and more internal and external spaces attached with the computer. Why it's doing that? Once we have defined something, once we have invented something, it might stay there, but it is basically the user that are demanding, and in order to meet the demand of the users, the computer system is required to enhance or required to upgrade it and required to add more and more feature. Hardware. Physical components are called the hardware. Physical component, something which is tangible. Tangible is something that you can touch, you can feel, you can have the feeling of that particular thing, and that's why it is called a tangible. So the physical component of the computer, and we'll talk about it, that what are the physical components. But basically you have got one screen, and that is the physical part of the computer, then a box which is called the system, the computer system, or sometimes the people call it as a CPU, but that contains a lot of things inside it. Then you have got a keyboard, then you have got the mouse. So these constitute basically the hardware of the computer. And the software, obviously computer carry out the instructions step by step. It process the information step by step. This step by step, what does it mean? Someone needs to tell the computer what is a step, what is the instruction, how to perform the calculation, how to calculate something, how to process something. So basically you need to educate or need to tell the computer, and you need to give the instructions to the computer. These instructions are called basically the software. This is a term which is a software or a program. This is an interchangeable term. So you have the something on the computer which you cannot touch, and that is called the software. This is intangible. Intangible means you can feel it, you can see that the something which is working for you, but you cannot touch it. So basically someone can give you the instructions, and you can listen to those instructions, you can follow those instructions, but you cannot touch those instructions. So just like that, there are certain instructions for the computer which are available to the computer to carry out the task, and these instructions are called software. We'll go into further detail later on. So hardware is a major component of the computer. So that may be characterized into different fields or different categories. This could be input devices, it could be output device, it could a CPU, then the memory and the storage devices. These are not the hard and fast 5 categories. Some books you find it out on with 3 categories. You can have the devices, peripheral devices, that can include the input devices, output devices and storage devices. And the second component could be the CPU, and the third component could be the memory. So this is the way of describing the hardware, way of characterizing the hardware. But basically these are the 5 physical components of the computer that constitute to one single computer, or the hardware called hardware of the computer. Input devices, as I already said, the keyboard is an input device through which you instruct to the computer, you provide the data to the computer, you key in the data into the computer. Then there is a mouse. Mouse is also a clicking device. You can pick up the instructions, you can instruct the computer, you can give the instructions to the computer by taking the pointer to any particular position on the screen and clicking it over there. Means you are telling the computer to do whatever is attached and associated to this particular pictorial, particular picture, particular graphics or particular text that is already placed onto the screen, that you are going to pick it up. So basically you are instructing the computer to do something with the help of the mouse. That's why the mouse is called an input device. Then you can have a scanner, just like the photocopier machine. You can put any picture onto the scanner, then you can scan it, take the copy, and then that copy and that picture is available to you on the screen and available within the computer where you can process it. And then you can have a pointer devices, and that pointer devices is just like the pointer that you can just write it down onto the screens. For the touch screens, you can use this pointer to provide the input to the computer. That is latest device that has been introduced. Output devices. Most common output device is basically the screen. the screen where you can display the data, where you can output the data, that data that you want to show to the user, you want to share it with the end users, or you want to provide the information to the user with the help of a device which is a monitor, which is a screen. But the monitors are obsoleted now. They're just like the old TVs, which were very huge and very wide, but now we have got very slim devices and like LCD TV. So these LCD devices have taken over the monitors and they are used as a screen. So that's why we can call it as a screen. Screen could be your LCD, could be your LED, or could be your monitor. Then the printer, you might require to have the hard copy, and that hard copy you are required to produce a letter, and that you want to send a letter to any organization, and that you want the computer to print a letter for you so that you can just sign it and send it to the end user. For that purpose you need a device that is called a printer. Then output could be in the form of voice, that the computer need to provide you something, and then the computer has a capability because it is integrated into the system. So output could be in the form of instructions, in the form of some audio signals, and that you can display it with the help of the speakers. Video signals are also possible, but the video signals are usually displayed onto the video screens or onto the screens. There are some categories of the devices which are both input and output. For example, in your latest the machines where you can have a touch pads, you can have a screen just like in your mobile screen, so you can just use the screen and you can just touch it, so you are not required to have the mouse to point it out any particular pictorial graphics or a text. So you have a touch screen, and that touch screen also provides you the output also. So this touch screen could be considered as input and output. Similarly, there is a device which is called a console. This console is just like a printer, but it also attached with the keyboard also. So basically you have got a keyboard, then you have got a printing like device combined together into form of one single device. This device is called a console, that you can instruct the computer using the keypad provided. Whatever you will type is printed onto the computer, and the computer can also provide you the output in the form of hard copy, means a paper, and that machine contains both input and output. So the console of the computer is also an example of the input as well as the output device. Central processing unit. There is a box usually that you can just place it across your screen. This box, people call it as a CPU, but it is more than that because it also contains the devices also. For example, it contains some storage devices that I will discuss later on. That is part of that particular box, and it also contains some other part which is not just the CPU, and basically it just contains one of the part which is CPU. What is CPU? Is a central processing unit. People call it as a brain of the computer. Does the computer has a brain is debatable, because the computer cannot think. So I'll talk about it later on. But people assume that the computer has got brain, computer can take decision. Yes, the computer can take decision on the basis of the input, but it does not have brain as per my understanding. Two parts which are the part of the central processing unit is the arithmetic logic unit and the control unit. So the CPU, that contains the control unit and the arithmetic logic unit. What is a control unit? The CPU, the component of the CPU, which is called a control unit, it directs and coordinates the flow of data through the CPU and from the CPU. So the data which is flown out of the central processing unit and going into the central processing unit is controlled by the control unit. So the people say that the role of the control unit is just like a traffic cop. Just like a traffic cop controls the signal and control the traffic sitting at the or standing at the square of any boulevard or anywhere. So this is the job of the control unit. To control the traffic means they control the data, traffic of the data. So CPU instructions set is also built into the control unit. Every control unit, every CPU can execute certain instructions. These instructions are already built into the computer. Means they are predefined instructions which are available into the computer. These instructions are on a very low level instructions, and you can just define your instruction by using these very small instructions. Basically, this is a very low level language in which these instructions are provided. So maybe your one instructions might require to have 5 or 6 or 10 instructions which are available to the CPU in order to obey your one single instruction. For example, you might call someone to bring the report from for the last revenue earned by your organization. So this is one single instruction, but the person which is required to bring the report might require to break this instruction into 10 or 12 instructions and collect that information, combine that information, put it together, make a summary, prepare a printout and present it. Just like you can give a computer any instruction, and that instruction is again broken up into the small instructions, sub-instructions, and these sub-instructions, which are the basic instructions, are built into the control unit. These are also called the commands of that CPU, commands of that particular processor or central processing unit that can execute these commands. So arithmetic logic unit, basically, if you see that it has got the 3 types of operations that can be performed, and these 3 types of operations, it can perform arithmetic operations, which are addition, subtraction, multiplication, division, and maybe you may call some other also operations which are related to that we will learn in this particular course also. For example, modulus operation or the integer remainder. But that is the prime job is the plus minus. Arithmetic operations is plus minus division and multiplication, we can say that. Then comparison, you can compare the 2 quantities whether they are equal or they are not equal. The quantity A and quantity B are equal, or A is greater than B or A is less than B. These are basically the equality functions, and these are used for the comparison. So this is also done by the arithmetic logic unit. And then there are some logical operations that can be performed, and these logical operations are AND, OR, and NOT. So these are the basically called the operations which are related with the computers, that if A is greater than B and B is greater than C. So this AND is basically called that logical operator, and this logical operation is also performed by the arithmetic logic unit. So control unit performs the control and has got the instructions which are executed, and arithmetic logic unit has got these operations that can be performed by the central processing unit. Then comes very important component, which is called the memory of the computer. The memory of the computer has got 2 categories. One is called volatile memory, and another one is called non-volatile memory. Volatile memory is dependent upon power. If you lose a power, then you lose this particular memory. Means the information is retained into the memory of the computer as long as the power is available to the computer. Once the power is switched off, then whatever information you have maintained in the memory and in the volatile memory of the computer is lost. Then there is a non-volatile memory. So that does not require the power every time. So there are certain technologies and techniques available through which information can be retained into this type of memory even if the power is not available. So the purpose of the memory is to store the data or program, but this memory, concept of this memory is not like the concept of the memory of the human being. Memory of the human being is basically something which is related to remember something, जिसको हम उर्दू में कहते हैं याददाश्त. तो ये वो memory नहीं है जिसको याददाश्त कहा जाए. Okay, to remember something. This memory you may have related with the workspace. Workspace means, for example, the table of a worker. The tabletop of a worker is the workspace available to that worker. Any worker is required to have a workspace, have a table to carry out certain tasks. So the worker comes up in the morning, and in early days when we don't have the computer, we used to have the typewriter. So worker used to place the typewriter on the table. Similarly, the computer loads the information regarding the screens or regarding the printer and load it into the memory of the computer, and it requires some space to load that information regarding printer or that the screen. Then the worker might place a clock onto the table. Similarly, the computer also loads the clock, and that could be the time of the day or the time of the computer. So that is also loaded into the memory of the computer. Then suppose the boss has directed the worker to provide the same example, to provide the revenue of the last week. What the worker is required to do will open up the almirah and take a file out and open this file up onto the top of the table, and then this top of the table is the workspace where the file is open up, and then we'll read out the information and type it out onto the typewriter. Similarly, the file is opened up into the memory of the computer, and from the memory of the computer the CPU reads the information and produce the output and produce a printout. So basically we can say that the memory is just like the workspace. The larger the table the worker has, the more the speed of the more efficiently the worker could perform. And suppose the table is too small and simultaneously the worker is required to open up multiple files. So what the worker will do, will close down one file, put it back, and then open up the second file. But if the table is very large, he might be able to open up multiple files simultaneously on the table. Similarly, if the memory of the computer is very large, then you might be able to open up number of files simultaneously in the memory of the computer. So I think that you should have a very good understanding now that what is meant by the memory of the computer. Then there are different types. As I said, it's a volatile and non-volatile. The random access memory, which is called a RAM. This RAM is a volatile memory. This is the primary memory of the computer, and that stores the current information which is being processed by the CPU. So this RAM is attached with the CPU, that's why it is very fast and it contains the information which is readily available to the CPU. Then comes the ROM, read-only memory, which is non-volatile memory. It retains the information even if the power is not available. So it's a permanent storage, and normally it holds the information regarding the boot up sequence of the computer. At the time you switch on your computer, your system is required to go through certain sequence which is called a booting sequence of your machine, and that loads the operating system. So what is operating system? I'll explain you later on. So this information should be available to the system, that how should the computer is going to boot up. That relevant information is available usually and provided to the computer in the form of a chip, and that chip is called ROM, which is read-only memory. Then we have got memory which is very, very fast, and this memory is within the central processing unit. Means there are certain storage space which is called the registers, and these registers are within the CPU. So since they are within the CPU, that's why they are very fast and available to the CPU within the CPU. And this the storage means the register contains the information which is CPU is going to process that particular moment. So at the time the CPU is going to process certain information, it is going to pick up the information available within the CPU, and that storage that is available within the CPU is the registers, where the information is retained and the information is present, and the CPU simply picks up that information and process the information. Since this particular storage is available within the CPU, which is the most prestigious and most expensive place, that's why this storage is very small in size, it's very limited in size, and it is very expensive to have the larger storage provided in the CPU, because it will increase the cost of that CPU. So in order to optimize the cost of the CPU, this storage is usually very limited and considered very expensive and considered very luxury. Then there are certain storage devices where you can keep this information, and that information you want to keep it for the longer period of time. So there are number of devices which are available. They are different from RAM because they don't require any power, and examples could be, which is very familiar and you should know that, and that is your CDs and DVDs. This is a storage that is available and that can retain the information, but you know that you can keep the information, and even you can keep this CD and DVD in your pocket, so obviously no power is required. Then the magnetic storage. Magnetic storage is basically the hard disk and the floppy disk, and currently these are the USB drives also. These are available, and basically these are the magnetic material, and this is an electromagnetic phenomena through which you can put the information there. So you can have a magnetized and non-magnetized field of information to save the information in the form of ones and zeros, or basically this also contains something which are the cells which are burnt and non-burnt, so you can just store ones and zeros. So different technologies available nowadays to retain the information or to record the information onto the CDs. Maybe if we could find time, we'll talk about this technology also. Then the system software. We talked about the software, said these are the instructions. Then we need to categorize these information. Some software which is called a system software that is available with the computer. This system software is required to operate the computer. This system software is required to maintain the computer. So it could be either the operating system or it could be the device driver. Device driver basically are the piece of software that educate the computer to deal with the devices, to deal with the I/O devices, to deal with the storage devices, to deal with the external world. So whatever device the external world is required to attach with your computer, that education needs to be provided to the computer, and this education, this information is provided with the help of piece of software which is called a device driver. So you have got a multiple operating systems, and most common is the Microsoft Windows. You can have a Windows 7, you can have Windows NT, you can have any type of Windows servers you can have, and that are different flavors available to one platform, under one platform, which is called a Microsoft. Then you can have parallel operating system which are called Unix operating system, or you can have a Linux operating system. And the difference between Unix and Linux is that the Linux is freely available, it's an open source, and whereas the Unix is copyrighted one, but otherwise both have the same characteristics. Then you have got another Ubuntu. Ubuntu is the operating system that simulates a Linux environment on your Microsoft environment. So basically this is also the type of operating system which has got its own characteristics. Maybe we'll teach you more in detail in the course of the operating systems. Then comes some application software. The system software only required to maintain the computer, to process the computer, to process the information and operate the machine. But if you are required to process the information with reference to the users, with reference to the utilization of the computer fruitfully by the user, then you need a software which is called an application software. Suppose you are required to write down the letters to the chief executives of different organizations, so you need the assistance from the computer. You need an application software, and that application software could be your Microsoft Word. You can use Word to write down the letter. Then this application software will help you writing a letter, help you finding out your spelling mistakes, help you in organizing and formatting your text. These are features which are available in Microsoft Word, and that is the information, that is the application software, and all these facilities are available under this application software. In this course I'll be using a lot of slides, and this one is also a slide that I have prepared in the PowerPoint. So the PowerPoint is also from the Microsoft, and that is the application software that is required to prepare the presentation. So these are the different logos of the Microsoft. Then there is another application software which is very common nowadays, which is a search engine, which is called a Google. By itself it has grown almost as high or as equal to the Microsoft also. So the Google by itself is an organization providing you a lot of online information, and that is through search engine, which is an application software. Then you sometimes require a utility program. That is also a piece of software, but it is neither a system software nor an application software. So sometimes you are required to maintain the machine or maintain your data. I can give you the example that you are required to take up a backup. Backup means that you want to keep a duplicate copy, that you want to keep it at a safe place, that if your computer crashes or it goes out of order, then still whatever efforts you have done, you would like to retain the data available to you, that you can keep it onto some separate media, and for that purpose you need to take the backups. And then you need to organize the files on your computers, and for that purpose you can use the utility software which are available provided by the Norton. So the Norton utilities are very useful, and that also includes the screensavers also. If you just leave the one picture on the monitor of the screen of the computer, then the glowing that particular picture for a long period of time leads an impression onto that particular screen. In order to avoid that permanent the impression that is left on that to the screen, we usually whenever you are not doing anything, then whatever is printed and available onto the screen, we run the screensavers, and these screensavers are the different pictures which are rotating, which are changing its position, so the permanent patterns are not retained there. Then there are certain viruses that might corrupt or destroy your data, so you are required to basically safeguard your files. For that purpose you might require to have an antivirus, and that antivirus is also considered as a utility program. Let's quickly talk about that how this CPU works. So basically CPU perform any operation in 4 steps. What are these 4 steps? These 4 steps are called fetch, decode, execute, and store. Fetch means to obtain a program instructions or data item from the memory. Whatever instruction that you want to give to the computer is first loaded into the memory of the computer. Then this information is loaded into the CPU. What does it mean? That it is taken from the memory into the registers available within the CPU that we have just talked about few minutes back. So from the memory you are required to take this information into the CPU. This process is called fetch. Fetch the data or fetch the instruction. Decode. Then the system should require that what type of command, single command or multiple command, the system is going to execute in order to obey or in order to execute that instructions. This is called decode. So after fetch you are required to decode, means what to do next, and then execute. Execute means do. If you know what you have to do it, now you have to do it. It is called execute. So carry out the command, carry out the execution. So if you carry out certain execution, then you are required to save the data also. So how can you save the data? You will store the data, means you have to empty those registers and all the process information you are required to take back and put it into the memory of the computer. So 4 steps: fetch, decode, execute, and store. So these are the 4 basic operations that are performed by the CPU. And for performing these 4 operations, we call it as a machine cycle. This machine cycle comprises 2 parts, I time and E time. I time is called instructions time. During the instructions time, the computer performs the 2 steps out of 4 that we have discussed. Means the computer fetch and decode in the instruction time, or in short, I time. Then in the next half cycle, which is called execution time, and in which the computer execute the instruction and save the result back into the memory of the computer. So carrying out the 4 steps, which is the machine cycle of the computer, is split up into the 2 more concepts as the instruction time and the execution time. Then it's very basic question that how the CPU synchronizes its task with the multiple devices attached. The memory is also attached with the computer. If the memory is attached with the computer, then the CPU has to synchronize it to the memory. The input device is also attached with the computer. It needs to synchronize it with the input device, whether the input device has sent the data, whether the sent data has properly received by the memory of the computer. So in that case, you need to synchronize the memory of the computer with the input device. So in order to synchronize, you need to have some mechanism. So that mechanism is basically the clock of the computer. The clock of the computer, which is a digital clock. Digital clock means it is got either 0 or 1. It is got square waves. So with the help of this clock, with the help of this rising pulse starting a clock cycle, basically this is one clock cycle, starting from this, going up, going down, going this. So this starts the next cycle. So this constitutes one tick is a one cycle. So the faster the clock, the faster the CPU will work, and CPU will execute the instruction much quickly if the clock is very fast, because the CPU has to do it in some few machine cycles. The job is done few machine cycle. If the machine cycle means, you know, the time period is basically inversely proportional to the frequency. What is the frequency? Frequency is the number of clock pulses in per unit time. They are vice versa. So faster the clock means you have more pulses in 1 unit time. So you can carry out more machine cycles in per unit time, means you can carry out more instructions per unit time. So faster the clock, the faster the machine. So we started with the machines having the kilohertz, and then we had the machines in the recent past that used to process in the megahertz, and now we have got the processor that can carry out the task in the gigahertz. So hertz is basically the cycles per second. Cycles per second. Then there are different types of the computer. We can categorize the computer into the supercomputers, the mini computers, mainframe computers, and microcontrollers. The supercomputer is the largest one, whereas the microcontroller are the smallest one among the four. So this is the characteristics: supercomputers, mainframe computers, mini computers, and microcontroller. So this is the example of the supercomputer. Most powerful computers, physically larger in size, so hundreds and thousands of processors that can process huge amount of data. Examples are the IBM ASCI, White, the Cray computer. These computers are available in the Europe, and they can carry out the task in a very fast, and they are basically used for a specialized task which is called the simulations, and they can simulate any process that might happen in the past, any process that might have happened in the future, or they can have a number of fields area where you can use these computers. But normally for the third world, these computers are not available. So these computers are normally not available to the third world. Mainframe computers used by the banks, airlines, insurance companies, they are still the machines that can carry out the task very fast as compared to the personal computer that I'll talk about later on. So they can carry out millions of instructions, rather we can say the trillions of instructions per second. So they are usually for the larger in size, so not the small. They occupy larger space, and they have got the dumb terminal. Dumb terminals is a terminal that just contain a monitor and contain a keyboard. So they are called dumb terminal, but they are intelligent terminals. Their terminals are attached to the mainframe computer. So on the one mainframe computer you can attach 16, 32, 64 or even 128 terminals. So the mainframe computer can simultaneously serve a few hundred people, and can each and every person assumes that the computer is carrying out the task for that particular user only. So they are also very fast machines, and there are quite a good number of mainframe computers which are available in Pakistan also. Then the mini computers, in between the your PCs and the mainframe computer, there are computer which are called mini computers. Still they provide a multi-user. Mainframe, I said that they can have few hundreds of users that can simultaneously work on the computer, but if you can reduce the number of size, then still the computer can provide the capability of the multi-users that it can satisfy or carry out the task for the multi-users simultaneously. So these computers are called mini computers, and these are basically the mid-range computers. For example, Spark computers, Power computers, PDP-11, PDP-7. These are all the computers which have which can be considered the as a mini computer. I have given here a few examples of the mini computers also. Finally, the PCs, your personal computers. These first personal computers are also called the microcomputers. You can have a laptop, you can have a variety of laptops, you can have a desktop, and you can have a notebook, you can have tablets. These are all basically the examples of the microcontrollers. Or even nowadays you can have a handheld computers, or smartphones also have the capability of processing the data. So this is basically the category where you can put in your personal computer. Usually one personal means one person, so it can carry out the task for one particular person. It can also carry out a multitasking task. Multitasking is mean more than one task simultaneously, but it may not be for the multi-user. It can be for one single user. For example, your desktop computer can perform the internet services for you you can just download something, simultaneously you can write a letter, simultaneously you can print something onto the printer. So these are the three different tasks that you can assign your personal computer, but still the user could be a single user. Okay, so this is the example of the multitasking. Then comes the microcontrollers. Controllers are basically the customized controller for the customized devices. Basically they are embedded into the system. For example, you might have a microcontroller embedded on your washing machine, automatic washing machine. You might have a microcontroller controlling your refrigerator, controlling your microwave oven. So these are basically the controllers which are embedded, which are inserted for carrying out some customized job, and they are very small in nature. They are very small chips, but still they can process the data as if they are the processed by the computer. So these are called very small, and they are even your wristwatch can have the microcontroller, and you can carry out number of tasks on your wristwatch. Or on your mobile phone, yes, you can have you have it, because your mobile phone can also process number of tasks, number of data. That's why you have also got the operating systems also. You can have Symbian phones where you have a Symbian operating system. You can have an Android operating system for your mobile phone. So obviously there is an operating system, so there is a controller or there is a processor available. So they are embedded into the appliances. So students, before I conclude this particular lesson, I would like to teach you the concept of IT. The people ask, the student asks, and a lot of people will ask you, what is an IT? Still, people are still confused, and but it's nothing to be confused. I can give you a very detailed concept that can distinguish between IT and the computer science. So what is IT? In order to understand IT, you should know that the computer is a device that uses a digital signal. वो जो मैंने clock अभी आपको बताई थी, that is a digital signal, and this is the clock of the computer. And computer were working as soon as we have invented the computers. We invented the computer using this digital signal. Then there was another industry that was a very powerful industry, which was the communication industry, and that is using the communication devices. So this industry used the analog signal. And what is this analog signal? This is basically the analog signal. So the computer were working with the digital signals, and the communication devices were working with an analog signal. But later on, in the recent past, 10 years back, these communication devices started working with the digital signal, and we have introduced the digital communication. Once we had the digital communication, it was very optimal, it was easy, and it was easy to process and maintain, and therefore the communication devices started working in the digital, with the digital signals. Okay, so the computers, they were already working in the digital signal, and communication devices also started working in the digital signal. So what happened? There was a natural merger between the computers and the communication. So the computers and communications devices were merged together. The computer started providing you this communication. Okay, you have launched internet, you have attached a fax machine, the facilities available to you. You can talk, you can have a video conferencing facility, you can have an audio conferencing facility. So you are doing the communication with the help of the computer, because the communication devices are integrated into the computer. So these computers and communications are blended together into a single device. Then There were few more devices. For example, mass storage were provided to the computer, having this base of the digital base. And then there are consumer electronics also, because the embedded controller have gone into the consumer electronics also, that we have talked about, the embedded systems where we have this microcontroller, and you know that this microcontroller work basically is a part of the computer. They work in the digital signals. Then your entertainment, the multimedia, they all were integrated together. So the computers, the communication, the mass storage, the consumer electronics, the entertainment, the multimedia, they all came in and integrated into the signal, into the one single टेक्नोलॉजी. और इस भानुमति के कुनबे का जो नाम रखा वो that name was information technology. So information technology is nothing but the combination of computers, communication and other related industrial industries. Okay, so I hope now you know what is IT, and you know the difference between IT and computer science and IT and communication. Those were the independent fields, but when we say IT, it's mean everything in under one name and under one technology, which is called information technology or IT. So students, with this we conclude the topic of the today's lesson, and maybe I've got a practice quiz. Today we have learned, since it was the first lecture, so just to, if you have missed something, so I will advise you to go back and listen it again and try to answer this question. That is, what is the difference between the data and information? What is the difference between volatile and non-volatile memory? I'm sure that you know it now, but if you don't, then go back and listen and repeat this lesson again. Memory is used for, what is the purpose of the memory? What is the use of the memory? What does computer do in I time and E time? How does the CPU synchronizes with other components of the computer? Can you name one or two devices which have the characteristics of both input as well as output? Name at least two operating systems. I've given you name of the 3, 4, 5 operating system. Can you repeat it? Can you give me the name of the 2 operating systems only? What is the use of these embedded systems? And finally, what is information technology? So with this we conclude lecture number now. We will be meeting again inshallah in the next lecture. Till then, Khuda Hafiz. Allah Nigehbar.